All right, so we've spent a bunch of time talking about the i3X API. Now, let's get practical. Let's see what happens when we hook it up to one of the most common data sources you'll find on any factory floor, an MTConnect agent. And that brings up the big question, right? How do you actually take the super detailed, structured world of an MTConnect's device model and translate it one for one into the i3X address space? Well, the answer is something called the MTConnect i3X companion specification. And look, this isn't about guesswork or making things up as you go. It's a complete, official rulebook. It lays out the exact mapping for every single device, every component, and every data item. Okay, let's dive right in. First things first, how does that basic structure, the objects and their unique IDs, get translated from that MTConnect XML tree into an actual i3X object instance?
The core idea here is actually super simple. Every single element you see in MTConnect, whether it's the top-level device or a tiny position data item, becomes its own separate object in i3X. That's it. It's a really clean one-to-one mapping.
So how do we make sure every one of those new objects can be found? The element ID is the secret sauce, and the rule for creating it is both simple and really powerful. You just take the device's UUID, add a colon, and then stick the MTConnect element's ID on the end. Bam! That guarantees a globally unique identifier for every single thing. And that same basic logic just keeps going for all the other metadata. The type ID? That maps to a specific object type. The parent ID? That's what builds the hierarchy. And the display name gives you that nice, human-readable label. The spec is even smart about duplicate names. Let's say you have multiple linear axes under one parent. It just adds the MTConnect name in brackets to tell them apart. Simple. All right, building on that structure, we get to a really elegant concept in the spec, the two-tier hierarchy. And believe it or not, this whole system is controlled by just one single flag, isComposition. So here's how it works. The model basically splits the hierarchy into two types. First, you've got these organizational containers, things like axis or systems. Their only job is structure. They just group things together. So they get isComposition false. But then you have the components that actually hold the data, like a linear axis. Its data items are seen as part of what it is, so they get marked with isComposition true. So why should you care about this? Well, it completely changes how you get your data. If you ask for data from an organizational container, the API smartly stops right at that boundary. It won't go digging through every single child, which saves you from a massive data overload. But if you query a data-bearing component, like our linear x-axis, the API gives you everything inside it. Position, load, condition, all in one super efficient call. Okay, we've got the structure mapped out. Now let's talk about the data itself. How do those real-time observations from MTConnect get translated into i3X's standard VQT, that's value, quality, timestamp, structure? For simple values, it's totally straightforward. An MTConnect sample, it just becomes a JSON number. Easy. But the real magic is how conditions are handled. Instead of just a flat string, the spec maps them to a structured JSON object. What does that mean? Well, if you have multiple faults active at once, each one gets its own key. This preserves all of that rich, multi-branch fault data right from the source. Nothing gets lost. Now, MTConnect doesn't actually have a quality field, so the companion spec does something pretty clever. It figures it out. A normal, valid observation. That's rated good. If data goes unavailable and we never had a value before, well, that's bad. But what if it was good and then it went unavailable? The quality becomes uncertain. It's a really practical way to add that extra layer of context that's so important. But, a machine's data model isn't always a simple tree, right? It's more complex than that. And this is where the spec really shines, by handling all those complex non-hierarchical relationships and building a true data graph. And here's how it pulls that off. Every single reference type in MTConnect gets a direct one-to-one mapping to a relationship in i3X. So component ref becomes has component ref, source becomes has source. You get the idea. It's a simple rule, but it means that whole web of connections inside the data is kept perfectly intact. The mapping even goes a step further. It can actually derive new, valuable information. By looking at the structure parent and child pairs in the MTConnect model, the spec can figure out kinematic relationships, like which component is mounted on another. That's data you didn't even have to start with. So the big takeaway here is that this isn't a partial fix, it's a complete really well thought out solution. The full mapping, we're talking objects, types, relationships, values, conditions, the whole shebang is all meticulously defined right there in the MTConnect i3X companion spec.
And that naturally leads to the last question, doesn't it? Where can you go to read this whole specification for yourself? It's an open standard, it's fully documented, and it's available for absolutely everyone. Just head on over to i3x.dev.